Okay, and this one we want to make it accurate to 4 decimal places. All right, so let's talk about this. The new x equals the old x minus the old y over the derivative. Okay, so what we need to do is, well, first things first, we've got to come up with what some of our zeros are. So you can do a couple things. You could, just do some guess and check. What's usually pretty useful is actually to go and take out a calculator and just get a good graph of the equation. See what it looks like when you graph it. So let's try to do that. Okay, now we're going to look at our graph. And there appears to be one. And it looks like it's around 1. It doesn't look like it's quite 1, though. So we're going to use 1 as our guess. And you can always trace 1 just to see what it is. And it's 1, 1. Okay, well, that's nice. And we're actually going to need that y value. So when we go back to our equation here, our new x value is equal to our old x value, which was 1, minus the y value, which is 1, over, well, we need f prime. So the first thing we want to do is find f prime of x, so that we're able to figure this out. And then we've got 5x to the fourth. I think I'm off the screen here. F prime of x equals 5x to the fourth plus 1. Okay, so now we got to find f prime of, well, the x1 is 1, so we've got 1 to the fourth is 1 times 5 is 5 plus 1 is 6. Okay, so our new value is x equals, well, 1 minus 1, 6, or 5, 6. Now, usually you're only going to do this like maybe once, maybe twice, but if you want to go to 4 decimal places, you have to do this until the decimal places they repeat, basically. Okay, so the way to do this nicely and not have to, really go crazy, because your new x value, so this is x2, this is our new x1, the x3 would be our old x value, which is now x1, which is 5, 6, really x2, minus f of 5, 6 over f prime of 5, 6. Now this can get kind of hairy, because now you got to do 5, 6, plug this in here. You got to plug in 5, 6 into your derivative. So if you're going to do this by hand, you generally would hope to only have to do it once, maybe twice. Like, I could probably figure this out. It wouldn't be terrible, but it's not something I want to do, and I really wouldn't want to do it after this. So what we're going to do is we're going to put this in the calculator for the most part. The problem with this program is the second that I click on the calculator, it's going to all go away. So 5, 6 is my answer. Might have to do a little bouncing back and forth here. Alright, so we're going to take 5, 6, which is, first off, I'm going to get that in as an answer. So that's my answer on the screen. And so I'm going to take my answer, which is my last thing, minus the function at that. So, and we need to end up dividing that. So second answer to the fifth plus second answer minus 1. So every time that you want to bring up the old x, you're just going to use the answer button. So get the old x. So like if I wanted to do the first one, I would hit 1, enter, so that's the answer. I wouldn't type in 1s here because then I can't repeat this. Alright, now this is divided by the derivative, which would be 5 answer to the fourth, and then plus, it was just 1. It wasn't x, it's just 1. Alright, so that will calculate my next value. Okay, well, I wanted to go till I have 4 decimal places the same. So far I haven't have any decimal places the same. So if I hit enter again, though, it will run it again. Now, we are going to be accurate to 1 decimal place. This 7 isn't going to jump down to 6 and going to jump down to 5, but these numbers are going to pretty quick. So this will be the first, well, 1, 1 was our first choice. So this is our second, third, fourth. Oh, now look at this. Now I got 2 decimal places the same. Oh, look at that. Now all of a sudden I jumped up to almost the entire calculator. So what it does, sometimes it's kind of rough off the beginning, and then it really centers around the actual zero very, very quickly. Now, I only need 4 decimal places, so here I'm good. 0.7549 or 8. Calculus you can truncate, but if it says round to 4 decimal places, I would round. When you just have the 3 decimal places that the AP exam requires, you can round or truncate. So the answer should be 0.7549. Now if I keep on going, this is going to really just repeat the same thing. Another thing we can do is we can check our 0 on the calculator, and you gotta go left, go to the right, and you guess. And you better get basically the exact same thing that we did before. Now you notice it's a little bit different. And we got the 49, but 0.754877. I don't think that's what it was settled on when we did. Oh yeah, it did. Never mind. I thought those were 2's. So you get the exact same thing that you would before. Either way. All right. So let's go through one more here. Now, one of the nifty things you can do with this is you can approximate basically any root you want to. That's probably more important than anything else. You ever been able to figure out what the square root of 5 was? That's kind of a tricky thing, right? So, to do this, the first thing you do is you come up with an. So this is kind of an interesting use of Newton's method, to be able to approximate any real root that you want to. So to get this root, the first thing we need, well, not x equals, but we need an equation. How about this? How about x squared minus 5? That has a 0 at root 5. So if we were to find my x-intercepts of this, set this equals 0, and I bring it over, x squared equals 5, x equals plus or minus root 5. Okay, so I figured out what I wanted. This is the equation, and I'm looking for the zeros. And I'm actually looking for the positive of the 2. There's 2 actual ones here. But I'm just going to choose a value that's closer to root 5, so something like 2. Because root 4 is 2, so, and if I went up to root 9, that would be 3, but 2 is much closer. So, that's our old value. So we're no longer doing 5/6 here like we did before. We're using 2. And we're plugging into this equation. So f of 2 is -1. So we have our new x value is -1. Oh, sorry. 2 minus -1 over, and then we need to do our derivative. So f prime 2x, and so that's over 4. So I should know it's bigger than 2 because that would be square root of 4. So we end up with 2.25. Okay, so that's our first iteration. So our new value, as we take our old value, 2.25 minus, and then we got to do 2.25 squared minus 5. So this is where you start going into the calculator. Over, well, the derivative, 2 times 2.25. You come with that number, and then the next value is the answer for whatever you got on this, minus the answer squared over 2 answer. So that would be your third iteration. Now we can bring out the calculator to do this, but you basically do exactly that, and then whatever that is your new value. And that's how you can use Newton's method to approximate the square root of 5. Actually, let's kind of run this out real quick and just see what we get, because it's kind of fun to do it. Actually, I'll let you do that. You do that yourself, and then also type in the square root of 5 and see how close you end up getting after only 3. And you'll get a lot closer if you do 4.